Alright, so this past week we've been talking about motion graphs. More specifically, we've been talking about a distance time graph. And so we learned how to read and interpret graphs that show distance over time. And now we're going to move on to a second type of graph. Alright, and that's known as a speed time graph. Alright, so these two graphs are different. They show different things. Your distance time graph is going to show distance over time. Your speed time graph is, if you haven't guessed it yet, going to show speed over time. Alright, so when we looked at the lines on the graph of a distance time graph, you were kind of focusing on distance. Now when we look at the lines on a speed time graph, it's going to show us how the speed either changes or stays the same as the line goes through the graph. Alright, so with speed time and distance time graphs, sometimes they can be a little confusing just because different sections of graphs mean different things for each one. So I would encourage you, as we're going through this mini lesson, to kind of take off your distance time graph cap and put on a speed time graph cap. Alright, so everything that we've learned this past week, I don't want you to get confused with what we're learning today. Alright, so kind of push that to the side for now and let's focus on this one thing and see if we can understand this, and then we'll look at the two graphs together maybe at the beginning of next week. Alright, so let's dive into speed time graphs and kind of talk about how we can read and interpret these. Alright, so let me get my PowerPoint. There we go. Alright, so a review from what we learned when we talked about speed, velocity, and acceleration is, what is acceleration? And we know that acceleration can occur in three ways, and that is if an object is speeding up, if an object is slowing down, or if an object is changing direction. Alright, so all three of these are types of acceleration. We know that your speed is going to change if your object is speeding up or slowing down, but your speed can be constant whenever something is changing direction. Alright, so this is important to know as we continue to move on talking about speed time graphs. Alright, so remember our buzzwords for speeding up and slowing down. So when we say something is speeding up, we tend to use the word accelerate. And then if we say something is slowing down, we use the word decelerate. Alright, and we haven't used deceleration a whole lot in class yet, but that is a word that you need to know. So if you're slowing down, you're decelerating. Alright, so like any graph, your speed time graph is going to have an x-axis and a y-axis. Alright, so on your speed time graph, your x-axis, which is this bottom part of your graph, is always going to represent your time. Alright, so seconds, minutes, hours, whatever the time variable is, it's going to be represented on your x-axis. Alright, your y-axis, which is the side of your graph, is always going to represent your speed. Alright, so it's going to have the word speed listed here, and so these numbers on the side would represent whatever your speed variables are going to be. Alright, so here we have an example of a speed time graph, and I know it's a speed time graph because I see speed written here on the side. If this said distance, then I know that would be a distance time graph. So we'll look more at that and how to distinguish between the two on Monday. But for right now, we're looking at a speed time graph. And so we see different things happening with our graph here. We see a line that's going up, we see a horizontal line, we see a line at y equals 0. So there's a lot of different things happening, and we're going to talk about what all the different sections mean. And so here's the part where it's different than a distance time graph. So if we had distance over here and we were looking at distance over time, then we know that this line right here is talking about distance. So if this line went up, then I know my object is gaining distance, and if it moved down, then I knew my object was going back to start. We talked all about that this week. But we're not looking at a distance time graph anymore. We're looking at a speed time graph. Alright, so this is different. So when we're looking at a speed time graph, then I know my line on the graph is going to represent what my speed is doing. Alright, so if I see an increase in my line, I know my speed is increasing. If I see a decrease in my line, my speed is decreasing. Alright, so this graph doesn't show me how far away something is moving or how far away from home something is. Alright, we're not looking at distance anymore. We're just looking at our speed over time. So is our speed increasing, decreasing, staying the same? Is it non-existent? What is my speed doing on the graph? That's what we're looking at. Alright, so let's talk about what the different lines on the graph would represent. So first we have a picture of a speed time graph, and we have a line that's resting on the x-axis. So it's all the way at the bottom at 0. Alright, so if my line is at 0, that means my speed is at 0. And if my speed is at 0, that means there's no movement happening. Alright, so my object is not moving, it's at rest. Alright, so we know right here is my x-axis. If my line of my graph is resting on that x-axis, or is not non-existent in my graph at all, then that means I have no speed. And if you're moving, you have to have some sort of speed. So if I don't have speed, that means I'm not moving. Alright, so that line that rests on the bottom of my graph is going to represent no movement. Alright, so let's move on to our next kind of graph. Alright, so now we have a horizontal line. And so remember, we're not thinking about distance time graphs anymore. We're thinking about speed time graphs. Alright, so this line no longer represents distance, it now represents time. Alright, so a straight horizontal line like this is going to mean something completely different in a speed time graph. Alright, so if I have a straight horizontal line, that means I have a constant speed. Alright, my object is moving at a constant speed. So my speed is not changing. Alright, and so this makes sense because I'm not looking at distance, I'm looking at speed. Alright, so if I have something moving at a constant speed, that speed's not going to go up, so those numbers aren't going to go up. If my speed is constant, it's also not going to go down. Alright, so my speed is going to stay at one number. So if this was at, y equals 5 right here, that means my speed was 5 meters per second. Alright, so if my speed is constant and stays at 5 meters per second, then my line's got to stay at y equals 5 the whole time. Alright, so this is going to be a constant speed. Alright, my speed's not increasing, my speed's not decreasing, it's staying at a constant rate. So I'm going to have a straight horizontal line for constant speed on a speed time graph. Alright, next we have a line that's increasing at a positive rate. So if this is speed, and my speed is increasing, then you guessed it, my object is speeding up. Alright, and so we use the word accelerate when something speeds up, so my object is accelerating. Alright, so your speed is increasing. And there's a V right here because sometimes they use the word velocity instead of speed on a speed time graph. It means the same thing. So here we have a speed time graph, so remember we're looking at our speed. So if my speed is going from 0 meters per second, or miles per hour, to 5 meters per second, and then it's increasing to 10 meters per second, my speed is going up. Alright, so we're looking at speed with this line, and if my speed is going up, it's going to show that by a line that's increasing. Alright, so a straight line that's going in the positive direction is going to show acceleration, positive acceleration, so speeding up. Alright, my object is moving faster. Alright, so if my line is moving down, so moving in the opposite direction, then that means I have deceleration. Alright, so my object is accelerating, but it's negative acceleration. Alright, so it's slowing down. Alright, so it would make sense that if I had a speed of, let's say, 8 meters per second, and then now it went down to 7 meters per second, 6 meters per second, 5 meters per second, 4 meters. So you can see how that's showing your speed is decreasing. Alright, it makes sense for it to go down the graph if it's decreasing. Alright, so this would be deceleration if it's shaped this way. So just to review, acceleration has a positive slope, or is going in the positive direction of the graph. deceleration has a negative slope, so it's facing the other way. Alright, so here we have a summary of what we've looked at. So in our speed time graph, we have acceleration happening. So our object is speeding up because our speed is increasing. Remember, this orange line represents speed. Up here we have a constant speed, so then your object is traveling at a constant rate of 10 meters per second. Alright, so constant speed here. Then that speed is going to decrease. Alright, so if your speed is decreasing, then you're decelerating or slowing down. Alright, down here, from 13 seconds to 16 seconds, we have a speed of 0. Alright, so if we have a speed of 0, that means our object is not moving, it's at rest. Alright, then our speed is accelerating again, so that means it's speeding back up. And then we end out our graph right here with a constant speed. So our speed stays the same at 5 meters per second. Alright, so these lines represent different things in a speed time graph than a distance time graph. But to me, a speed time graph honestly makes more sense because you can directly see what your speed is doing. Also want to note that you will not see any curved lines in a speed time graph. Alright, so there are no curved lines in a speed time graph. That's only on your distance time graph. So don't get that confused as well. The main thing to remember when trying to distinguish between the two, and we'll focus more on this on Monday, the first thing you should do when you look at a graph, anytime, is to look at this y-axis variable over here and see if it says distance, or sometimes they'll say position, or speed, or velocity. So if it says distance or position, you're looking at a distance time graph. If it says speed or velocity over here, then you know you're looking at a speed time graph. Alright, so anytime you're looking at a graph, or a motion graph to be specific, you need to look at your y-axis over here and see if it says distance or speed. Alright, so that will let you know what kind of graph you're looking at, and it matters because the different types of lines mean different things on each type of graph. For today, I'll go ahead and tell you we're just doing practice on speed time graphs. Alright, and probably tomorrow too. So we're just doing practice on speed time graphs today and tomorrow. On Monday, we're going to focus on doing both distance time graphs and speed time graphs. Alright, so today and tomorrow, just practice on speed time graphs. On Monday, we'll move on to both. Alright, so make sure that you have your notes filled in. You should have been filling in the blanks as you watched this video, and also make sure you draw the lines with the graphs that go with it so you'll have it as a reference. Use your notes today on all your activities. Alright, this is new stuff and I'm not there in person to teach it to you. So use your resources of your notes to help you out. That's the best way that you're going to get familiar with it is by looking at it and referencing it while you're doing your practice. Alright, so these are your notes to keep, page 135 in your notebook, and then you can move on to the rest of your activities in Schoology now.